Let me welcome the next speaker, who is Alexander Kornbrust. He's one of the most respected database security experts today. In the last 6 years, Alexander has reported more than 350 security bugs to Oracle and gave various presentations at security conferences like Black Hat, DEF CON, Blue Hat, HITB, and so on. This is his third year of presenting at Hacktivity, and this year he's also a member of the program committee. And I believe he's going to talk about the time frames of self-defending databases. So the floor is yours. Welcome.
Okay. Welcome, and I'm happy that you are here in my talk. So far, I had not so much luck in Budapest. Yesterday, my lenses broke in talk of Laszlo. Then in the evening, I tasted some of these little innocent paprika. And today, my laptop was not working. I want to talk about self-defending databases. And we talk a little bit how a database can detect an attack and what could we do against it. So nowadays, database web applications are often attacked from the outside, from the internet. And yesterday in Laszlo's talk, we did not hear anything about SQL injection, and here you will hear a lot of SQL injection. And the typical attacker is using a tool, and after the tool was retrieving the data from the web page, depending from the motivation, this data is often posted on typical web pages like Pastebin. And nowadays we have a lot of script kiddies and lazy people, so they run a tool, and with this tool, they can download data and attack websites without having a deep knowledge. And what is the problem? The problem is that the web applications are often vulnerable. And the solution is quite simple. We just have to fix all web applications and allow only the deployment of secure and pen-tested web application. But is this really realistic in the real world? So from my experience, less than 5 or 10% of the web applications are running without had the pen test. So it's not realistic because in the real world we don't have secure code. The majority of applications are not pen tested. Applications are often quite old. I know applications that are in the internet since 10 years without having a modification. And in the real world, it's difficult to get a patch or apply a patch. So you don't get a downtime and so on. So the idea of having secure code is nice, but it's not realistic. How does a SQL injection attack looks like? So I'm quite sure the majority here in the room has already experience with it. Nowadays, a lot of tools exist which are able to download direct from the application. So people are using a tool, or they start with Google to find a SQL injection vulnerability, and then they start crawling the entire web page, and they are looking for SQL injection vulnerabilities. Once they found it, they start downloading, identify the tables, and then they download the data. So the first step can start, for example, here with Google. If you look for OCI execute and the error message Aura 1756, you will find thousands of SQL injection vulnerabilities. For example, here we have a web page. They produce ceramics, and in some of the pages there's a single quote, and that's why a SQL injection error message is displayed. So if you use this string in Google, you will still find tons of vulnerable pages. Once you have such a page, you can start a tool. Here I'm using a Chinese product, and you specify the URL. Then you can specify what you are looking for. You can say how deep do you want to scan. And we are looking for SQL injection in this case. And then the tool starts. So by clicking on this green button, you can start searching for SQL injection. If the tool found something, you will see here the vulnerable URL. Then you see it's SQL injection, and you can also get a list of the tables. There are other tools like Havi or NetSparker, and they're also showing vulnerable tables. And the last step is to download the data. So this is another Chinese product, Pangolin. On the left side, you can see all the tables, and you can now select the columns you want to retrieve. And on the right side, you can see all the data retrieved from the column. And by using the Save button, you are able to save it in a CSV file. So nowadays, it's that easy to download the data. And from my experience, it takes less than 5 minutes before your data is lost. So once an attacker started an attack, you have 5 minutes to react, or 2 minutes. So in the real or perfect world, this is quite easy. So within 2 minutes, you are informing the responsible manager, and the manager calls his DBA, and the DBA is shutting down the database. Same question, is this realistic in a real organization? I don't think so. This time is too short for humans to react. The majority of companies do not have security in place, so they do not have a security information and event management system where they collect all the data. They do not have a security operation in place which is responsible for dealing with all these events. What happens, for example, in the middle of the night, what happens during the weekend, or if you are sitting here at Hacktivity. Then even with a CM solution, 2 minutes to react and to do something on an attacked system is quite a short time. And there are often side effects. So if you are the manager on duty, normally you are not that confident that you shut down the system. So even if you know an attack is ongoing, normally a manager on duty does not know the side effect. What happens if I remove the network cable from the system or if I shut down the system? That's why nothing happens and your data is gone. So we don't live in a perfect world, but we need a different approach. So you cannot count on humans because humans are too lazy, not confident enough, and too slow. So we need an automatic response. And the system itself has to detect the SQL injection vulnerability, and then it has to take the appropriate countermeasures. The question is, how can we detect a SQL injection vulnerability in a web application? So one place where we could do this could be a web application firewall. And the vendors of the web application firewalls, they are trying to sell you this advantage. You can block some certain attacks, but from my experience, there are always countermeasures how you can bypass web application firewalls. Then we have web servers. So you can use something like mod security to block SQL injection attacks, but here again, there are countermeasures to bypass this. Can we do it in the application? I don't think so, because the application is normally not aware what is a valid SQL statement and what is an attack. And the approach I'm showing here in this presentation is to let the database decide if the database is under attack or not. And this is not that difficult, because Oracle and also SQL Server are able to detect error messages. So whenever you start with a SQL injection attack, you normally start with an error. For example, you enter a single quote, and then you look what is the feedback of the application. And if you get something like quoted string not properly terminated, you know that you found a SQL injection vulnerability. And based on this attack, you are evolving the input, and finally you got a valid SQL statement, and with this valid SQL statement you can download data from the database. And this approach, looking for error messages, is quite good because the false positive rate is really, really low. So from my experience, 99% of the errors are really coming from an attack. That's why you can decide on this error message to do your countermeasures. And there are two different approaches. Oracle has a nice feature called error trigger. And with the error trigger, one second. See, Paprika. So with an error trigger, you can say if a special error occurs in the database, do something. And Microsoft SQL Server can do the same, but with a different concept with event notification. And what we are doing, we know that a SQL injection attack is creating special error messages. For example, this is also a typical error message. Query block has incorrect number of result columns. This happens if you are combining two SQL statements with a union, and one part of the union has a different result set than another part of the union. And here's an example. We have a normal statement, so this was the idea of the developer. Select customer name, customer ID, customer order from customer. And the attacker tries to append something like union select username, null, password from DBA users. And if this statement is, if the data types are correct, and if the number of result of columns is identical, then you get a result back. But in the real world, we need different attempts before we are able to find a valid SQL statement. So here we have a simple Oracle reports application, but this is valid for all kind of web applications. So we run it, and the output is the content of a table called emp. Oracle reports has a nice feature. If you append a parameter, param form is yes. In this case, a window pops up, and in this window you can modify the SQL statement. So it's a kind of SQL injection with a menu. And we are now overwriting this order by one with our select statement. Union select null, username, something. And what do you think will we see if we click on submit query? In the real world, an error message. Because the chances that you really find the right combination is quite low. So typically you are getting this error message, query block has incorrect number of result columns. So in this case, you can append a null. So what you have here, you can append null until this error message disappears. And once the error message disappears, you can see the result of the SQL injection in your normal web application. And this is called in-band SQL injection. And this alone, this statement now took the data from your system, and it's gone. So we have to react before someone is able to add all the statements to construct a valid SQL command. We have to react in this short time frame. And here I composed typical error messages. So all these error messages are common for SQL injection attacks. So I run the typical tools against vulnerable web applications, and then I collected what error messages occurred. And we can see here, this 1798, someone was trying to do a union select. Or if we are getting ORA 29257, this is an attempt via UTL in RDDR. So some tools are using this to create a specially crafted error message. And we know if this happens, that someone was stealing data. Or we have here missing left or right parenthesis, missing comma. If you are using SQL map is trying to do a division by 0. So if you find something, SQL map is dividing the result by 0, and this is creating an error message in Oracle. So you know if you are getting a lot of these error messages, the attacker is probably using SQL map. For SQL Server, at the moment there's less experience, but typical error messages like unclosed quotation mark before the character or syntax error converting the nvar value, these are also typical for SQL injection attacks in the SQL Server side. So what could we do? If we know one of these error messages I showed here, if they occur, we could just log it somewhere. We could send an email. My recommendation on a production system is to lock the user account, because then nobody else can connect to the database anymore. And you can and should terminate the session or terminate all the sessions. So this means someone is trying an attack, and then after he first created an error message in the database for SQL injection, you are locking the user and you terminate the session. From this point on, your system is no longer working. Some people say, oh, that's a denial of service and nobody else can work anymore. Yes, that's true, but if you have the choice between your data is posted on some website, your banking data, or your customers are not able to work for 1 or 2 hours, what would you prefer? And this is a management decision. So the manager can say, we prefer unavailability of the system over data theft. If you are not that confident, you can just send an email to a manager on duty. But my experience, nobody will react in this short time frame and the data is gone. To minimize the impact, it can be a good idea if you design web applications to have individual database accounts and connect strings for the individual applications. So one of my customers has, for example, Android application, iOS application, a web application, and you can create different user accounts. So if someone is trying to hack the application from Android, you can just lock the Android account, and all the other people can still continue to work. So this is one possibility to limit it. If you invest a little bit more time, you can only block special IP addresses. So you can say this attack is coming from this IP range or this IP address or from this country, and then you can say we are locking all the users coming from outside Hungary, for example. And it's also possible to differentiate between internal users, your employees, and external users. So even if the external users are blocked, your internal people can still work. And these error messages should only lock the system if they are coming from the application server. So if someone is using an interactive tool and he forgets a single quote, you should not lock the server. Only if the Tomcat or WebSphere application is creating this error message, you can lock the user. So this is the sample. Sorry. This is the sample for sample code for Oracle. So you can use this and you can play with it. So here we say after a server error occurred, what we do is we are first collecting stuff like program. What is the program who created this error message? And then in the next step, we have to recompose the SQL statement. That's one of the big advantages. You can see which SQL statement was creating the error. So if it was just a string like O'Leary, then you see it's probably a false positive. If this SQL statement contains a single quote or 1 equals 1 minus minus, then it's normally an attack. So here with this loop, we are reconstructing the SQL statement because Oracle is using 2000 byte blocks and we are concatenating all together. And then we say if the application server is called IIS and one of these errors occurred, then we know it was an attack. So we could send we could write it to a log table, we could send an email. Now we can log the user and terminate the session. And that's it. So you install this trigger in the database, and for every error coming from the Internet Information Server, in this case, you are locking the user. And the manager on duty, he has to decide, okay, he can look into the data, and he says this was a false positive, and then he re-enables the account. Or he says this was an attack, and then he has to think about further steps. I know this is not so easy, if it's in the middle of the night, but in this case, I would prefer that the system is down instead of letting someone else stealing the data from the outside. For SQL Server, I hadn't the time because at the moment I'm really busy to implement proof of concept. But SQL Server has a concept called event notification. And for event notification, you can say similar to Oracle, if a special condition or event occurs, please do something. So here in the bottom, it's difficult to read, but if you have the slides, you can easily see it. There's sample code for detecting deadlocks in the database. And instead of detecting deadlocks, you can do it for SQL injection. So if one of these 4 typical error messages occur, you can send an email, log the user, more or less the same. What could we do after we detected SQL injection? We said we can send an email, but emails is nowadays always problematic. You have so many emails, sometimes they are sent into the spam filter, and what happens in the night? So this is the smallest footprint, but it's normally not good for fast reaction. And what happens if you're on vacation and so on? So if you want to play with it to see, okay, do we have SQL injection? Then you can start with an email. This is also quite good for penetration testing. So let's say you have a penetration test, you can install this trigger, and you can see if the pen testers found SQL injection vulnerabilities. And sometimes you can even help them to make a better pen test because the statement which created the error message is written to a monitoring table. So if we really lock the database account and kill the session, the big advantage, the attack is stopped. But the problem, it's the system is no longer working. And here in the plenum, what do you think? Is it better to lock the user or let the attacker steal the data? What would you prefer? Who prefers that the data is lost? Who would lock the user account? Good. So normally if I talk to managers, most people say, oh, I would prefer letting the attacker stealing the data, and it's not that important. So you should discuss it with the management. And this is the big question. And normally a normal administrator or operating guy could not decide this answer. In my opinion, it's always easier to re-enable an account than locking an account. That's why the manager on duty should have the possibility to unlock the account again. If we talk about a concept, we also have to talk about false positives. I mentioned already the name, something like O'Leary with a single quote. So if someone is entering this name and your web application is vulnerable to SQL injection, the trigger will get an error message and the system is locked. But this is not a real attack. So the system is vulnerable and the attacker could steal the data, but here it was more an accident. And in this case, I would say it's probably okay to unlock the user and to continue the work, but you should fix this SQL injection vulnerability as soon as possible. And normally, based on the error messages, you can easily identify if it was an attack or not. Because the majority of the tools, they are using fixed strings. So based on the error message and the resulting SQL statement, which was causing this error, you can see which tool was used by the attacker. And if someone is using a tool, it's probably more a script kiddie. If someone is using custom SQL statements, it's probably a more professional attacker. So in this case, that's the only problem. You found a SQL injection vulnerability, but it was not abused. It was more an accident. And Another false positive, let's say a developer is writing a web application and this web application contains the incomplete SQL statement. So a single quote was missing. In this case also the error single quote is SQL statement is incomplete, is executed, the trigger fires and your user account is locked. So in this case the manager on duty has to detect that this is not a real attack and he can re-enable everything. So I already mentioned this idea to lock only a certain amount of groups like Android apps and so on. We can also hide, lock out only special IP addresses. We can also get additional information who was performing the attack from the web application server. Because at the database level, you see only the connect was coming from the web application. But you don't see the original user who was executing the statement. If you have a communication to the web server, you can find out who was doing it. Was the network coming via Tor? So if a Tor network is creating a SQL injection error message, this is normally a good indication for an attacker. But this needs much more time to implement. A normal error trigger can be implemented in 2 or 3 hours. If you have a back channel to the web application server, it takes more time, for example, 2 or 3 weeks before you have the communication and the application has to be modified as well. Another nice idea to find attackers is the usage of fake data or honey data. So what we do is we are creating in your web application tables which are not used by the application itself. For example, containing passwords or credit card numbers, depending from your application itself. And this unused data, this data is monitored by the trigger or by a system itself. In Oracle, we can use a feature called Virtual Private Database. And this feature is also a kind of trigger. And whenever someone is selecting from this fake data, you can lock the user. Because this data is not used by the application itself. And the only reason why someone is accessing it is an attacker looking around in your database. And from my experience, after finding a SQL injection attack in the database, attackers are often looking for tables like all tab columns or information schema columns. And this is also what I do if I do a pen test. I'm looking for typical columns like password, credit card, PVD, and depending from the region, what could be interesting. And if I find a table called password, then the first thing what I'm doing as a pen tester, I'm looking into this table. And using Virtual Private Database, we can detect if someone is selecting our table, and then we can do the same step. We can lock the user, we can send an email. And the implementation is quite simple. We create a table with juicy data. For example, here we call it username and password. And the naming convention should be similar to the application itself. So normally if you look at the table structure, some people start with a T underscore for table. So the table name should follow the naming convention of the original application. And then we are putting some data into it. Here we have 3 user accounts and a password. But this data is not used. And now we are creating a function with an unobvious name, pathcheck. And we say this pathcheck function can be added to our object user data. So whenever this table is selected, the function is executed and the function sends an email or locks the user. And this is a good idea because this data should never be selected from your web application server. And this is another idea, and you can combine this to let the database itself detect if the database is under attack or not. So I hope I could show that databases itself are able to detect an attack from typical SQL injection tools and also manual attacks. And in many cases, you can limit data loss if you lock the username. But the big dilemma is, do you really want to stop the service or do you want to stop the data loss? And the nicest, it's free, so you don't need special licenses from Microsoft or Oracle. You can start within implementing this error trigger. It takes 1 hour, 2 hours playing a little bit around, probably 1 or 2 days. Questions? Silence? What do you think about this idea? Could it be implemented? Yes? Two. So it's my concept. I haven't saw it so far, and here it's the first time that I'm giving a talk about it. Yes. So that's why it's up to you. In the real world, you should always start with a test system, probably starting with sending emails or some kind of notification. And then if you are more confident after 1 or 2 years, you could migrate it to production. Or you could do a mixture. If someone is doing a penetration test, you can use it to simulate this kind of external attacker. And I'm not aware that this concept is possible for MySQL or Sybase or PostgreSQL. So if someone has an idea if something like this would be possible, it would be nice if you give me some hint about this. Any other questions? Yes. Yes. So by terminating the session, I would always combine it with locking the user. So normally if you just lock the user, the session are still active. And if the session is active, you can still steal data out of it. That's why after locking the session, you have to terminate all the sessions. So if the script or the tool is trying to reconnect, this isn't working anymore. Another option would probably to slow down the connect attempts, to limit the amount of attacks per second. So this could also be a possibility to slow down the number of attacks. But I would prefer to lock the user. Does this answer your question? No. I heard this argument a few times. If your web application is vulnerable against SQL injection and they could steal everything from your system, then I think denial of service is the smallest problem. So normally an attacker is more interested to steal the data instead of shutting down your system. And in this case, if you see that this happens more often and someone is only trying to stop the service, you probably have to disable the trigger. That's one command, alter trigger name disable, and then this doesn't take place anymore. And then you probably have to add some rule at the web server saying, okay, all attempts from this IP address are blocked automatically. Something like this. Yeah.
I think it's a nice idea that we have this self-defending database
Yes. I know it's a hard decision. It's possible to identify also the web user, but you have to modify the web application itself. So in Oracle, you can use the DBMS application info to send the IP of the original requester of this web page. You can enhance the database session with this information. But I agree, if you have hundreds of users coming via the same connection, you have this dilemma. Should I accept the denial of service scenario, or should I accept the data loss? And in my opinion, if someone is using a tool like Pangolin, and he already started investigating, exploring SQL injection vulnerabilities on your system, it's only a question of minutes before he starts downloading data from your system. So it was also a similar case happened at Sony. The DBAs, or the application owner, detected that something was going on, but the attacker was able to steal a few hundred megabytes of data from the Sony database. And I think in case of Sony, they would have preferred a downtime instead of the data loss. But that's a management decision. At least now you have the option to say, okay, you can choose between this or that. But the best solution is to have good code that this could not happen. Okay. And thank you for listening to the talk, and enjoy the rest of the conference.